All right, well, welcome back. We're going to talk about recursive definitions and how to identify them in more simpler terms when dealing with arithmetic and geometric, when dealing with arithmetic and geometric sequences. Here we're going to write the first 5 terms of this arithmetic, or this recursive definition. And we're going to try to identify what this is going to be. So, starting off, we have our first term, which is 28. And so we want to find the second term. And if you notice right here, in order to get that, k has to equal 1. All right, so we're going to plug that in. So we have the first term minus 4. Now, when we have that minus 4, we're going to have 24. We find the third term. Obviously, k is going to equal 2 in this case. So we have a 2 minus 4. And you realize that we're taking each previous term, and it appears we are subtracting 4. And we see that from this right here. All right, subtract 4, this being the previous term, and we get that, that recursive equation. So we can just simply go through and finish this off real quick by taking 20, subtract 4, which is going to give us 16. And then the fifth term, take 16, subtract 4, which is going to give us 12. So we're subtracting 4 each time. So when we subtract 4 each time, all right, subtract 4 from previous term, we realize that this is some sort of pattern. And the pattern that it's dealing with is actually a linear pattern, has a slope or a common difference. All right, and this common difference means that this is an arithmetic sequence, all right, because it has that common difference of -4. Now, arithmetic sequence, so now we're going to find out what the nth term is. Now, the nth term, just so everybody realizes, the nth term is the last term. So when we talk about nth term, is the last term in the sequence. The last term in the sequence. But also, I like to stress that the nth term is actually an equation. All right? This is an equation of the sequence. All right? We're trying to figure out a formula or an equation for the sequence. So when you find an nth term, you're looking for an equation. If you don't have an equation, you did it wrong. So that was figure this out. Well, arithmetic is linear. Okay, it's a linear pattern. Well, linear patterns mean you have linear equations. So we can use point-slope form or slope-intercept form, but to put this in terms of a sequence. So what we have right here is I'm going to use point-slope form because that's what I like. My y value, just so everyone knows, is this, if we take it back from function notation and equations. But instead of having, all right, the y, we have a sub n. So we're going to have a sub n. My slope is my common difference. In this case, it's going to be -4. All right, -4 right there. So -4 is my slope. I have n for my x value, minus, now I need a term. Luckily, they give me a term right here, and I actually created 4 additional ones. So I have a point of my term, which is 1, comes from the n value, and my output, which is a term, the 28. So I plug that in there, and that's my nth term. Obviously, most of them like to have it in slope-intercept form, or simplified, so we'll simplify this. And we have a sub n equals -4n, all right, plus 32, and there's my slope-intercept form and the equation that I want. All right, so there is an example of arithmetic. Well, let's check out this one, another recursive definition, and I want to identify if this is arithmetic or geometric. Now, to do this, we want to figure out and identify what is happening to the previous terms. And obviously, the recursive, we can check this out. When you're arithmetic, arithmetic means you have a common difference. All right, as we said before. Geometric means you have a common ratio. Common ratio. All right, common ratio. Common difference means you're adding or subtracting from the previous term. From previous term. When you talk about common ratio, that means you are multiplying. Multiplying or dividing, which is the same thing, but just by the reciprocal, dividing, all right, from the previous term. We can read this. Probably can't. I can't read my own writing. All right, term. So by doing this, we can look at this and say, okay, what are we doing to the previous term? And we can figure this out by just writing out the first couple terms. All right, we have our first term there, so I'll find my second term. Plug that in there. We're using, and we're multiplying square root of 2 over 3 times our first term. Okay, because we plug in 1 in for k, and we have that. Well, you realize that we have then square root of 3 over 3 times 3. And yes, we just realized what I just said. We're multiplying, and we have the square root of 2. And from there, we're going to multiply the square root of 2 over 3, and we keep on doing that. So we actually are multiplying repeatedly. Because we are multiplying repeatedly, this is a geometric sequence. Geometric sequence. My common ratio, if you have this, is going to equal that multiple. That ratio is square root of 2 over 3. We can write out our equation then, if I wanted to write my nth term, which is our equation, our formula. And that comes from this formula right here. If you look at the previous tutorials, remember that a sub n equals first term times the ratio to n minus 1. That's the basic equation we can use. So I'll take my first term, which we have, which is 3, times my ratio, which is our common multiple that we're multiplying, square root of 2 over 3, and we just take that to the n minus 1. Bada bing, bada boom. That is our nth term, and we did above and beyond what we were asked to do, but hey, we're all overachievers, aren't we? So we went through 2 different examples of using recursive definitions and identifying if they're arithmetic or geometric, looking for whether they are adding or subtracting, that's arithmetic, or if they are multiplying or dividing, that's geometric, and it has a common ratio. Hope this helps you out, and there's going to be some additional tutorials on sequence and series coming up.